Okay, welcome back. So this is the third lecture on 7.1, and in previous lecture we figured out that in order to, when we have a linear function, and we're trying to find the derivative of its inverse, we simply find the derivative of the function and then we do the reciprocal, right? So we flip it and we get the derivative of the inverse, right? So now let's but this refers only to, applies only to linear functions, and let's extend it to all functions. Okay, so let's take a one-to-one function. Let's call it f of x and its inverse. I'm going to call it g of x, right? And that's the inverse of f of x. And right, you guys know that if I take an inverse of the original function, right, I go back to my x. Right? We've seen it before. Let me just quickly remind you, right? So I have my x here, and my y. So f maps x to y, right? This is my f. And now if I apply the inverse to it, it takes me back to x, right? So inverse of f of x is just x. Alright, so now we're going to take a derivative of it. So take a derivative. So here we have, right, two functions, a composition of two functions. So we need to apply the chain rule. So derivative of the, well, let's just write what we're doing. So d over dx of g of f of x. A lot of parentheses here. 1, 2, 3. Okay, and now on this side we have d over dx of x. Okay, so on the left side we need to apply the chain rule, right? We have outside function g and inside function f. Right, so the chain rule says we need to do derivative of the outside, leaving the inside unchanged, right, times the derivative of the inside. And here, right, derivative of x is just 1. Okay, so here is what we're looking for, right? Derivative of the inverse of f of x. So we're going to solve for it. So g prime of f of x, and divide by f prime of x, and I get 1 over f prime of x. Okay, yeah, so this is what we were after, right? Now we have a formula to figure out, to find the derivative of the inverse. Okay, so we could also write it like this. That's how it is in your textbook, I think. So yeah, derivative of the inverse of f of x is 1 over f prime of x. Okay, so this is our brilliant formula, and what it says is that if we want to find the derivative of the inverse of some function, we simply take the original function, take a derivative of it, right, and then do a reciprocal. This is 1. Alright, so example, just to illustrate how this works. So we have a function, so square root of x plus x squared plus 1 is 1 to 1, right? We're gonna, if we restrict the domain to this thing, x greater or equal than 0, and then we need to find derivative of its inverse, and also slope of a tangent line to a curve, right? The curve of the graph of the inverse, and at a certain point, of course, right? Okay. Okay, so we have our formula. It's this one here, so I'm not gonna rewrite it. I know that what I need to do, I need to take a derivative of the original, right? So f prime of x, d over dx of that x plus x squared plus 1. Okay, so here I'll have the first one, it's 1 over 2 squared of x plus 2x, and that's it. And derivative of 1 is nothing, 0. Okay, so that's my f prime of x. Well, so I'm almost done, right? So that derivative of the inverse, right, of f of x is the reciprocal of what I just found. So I just put it in the denominator, and that's it. Okay, so this is our first solution, the first question. Alright, and B was asking for the slope of the tangent line to that, right, to the curve, to this curve, to the inverse, graph of the inverse at 3, 1 at this point. Okay, and this curve. Okay, so let's maybe start with the picture of what's going on. Okay, so we have our line of symmetry, y equals x, and this is here's our inverse. Okay, it looks like this. So that's y equals inverse of x, of f of x. Okay, and this is our point, 1, 2, 3, maybe let's just put it here. Okay, so if this is we see how our inverse looks, we can also graph or sketch a graph of the original, right? So 1, 3, so the reflection of that point will be here, and we simply just sketch the mirror image of that graph. So this is y equals f of x, right? This is the original function, and coordinates of this point is 1, 3, or r1, 3. Okay, so now the formula for slope, right, is just the derivative of the inverse at that point. Right, so m equals inverse derivative of it, and now this is important. This is a pretty big pitfall for a lot of students. So here, right? This is the original function f of x here, right? But now x, when I'm looking at my original function, or I need to be looking at my original function, right, to determine what that x is, or what the x coordinate of that point is, and that actually is 1, right? So you cannot, at this point, you cannot substitute that 3 right in here, because this is my original function. This is not the inverse, right? Okay. So I have 1 here, and this was 1 over 2 squared of x, so it's 2 squared of 1, right? Plus 2x, so 2 times 1. Okay, so we calculated, so what is that? 1 over 2 plus 2. So 1 over 2 plus 4 over 2 is 5 over 2. So that's 2 over 5. Alright. So be careful here. Alright, so the slope, right, so where's that line? So that line is here, right? The tangent to my inverse at that point. Alright, so that slope here is 2 over 5. Okay? Well, we also know the slope here, right? You guys know what that is? Well, it's a reciprocal, right, of this one. So here, the slope of this one is m equals 5 over 2. Okay, so that concludes the lecture for 7.1. Yeah, so the important thing, right? If we want to take an inverse of a function, our original function needs to be a 1-to-1, right? So some functions are 1-to-1 by themselves, like for example, well, all linear functions, 2x plus 4, cubic functions, some of them, right? Not all. Yeah, so if we're dealing with a function that's not 1-to-1, right, then we need to restrict domain, and then we can find the inverse, right? We find the inverse by solving for x first, and then interchanging x's and y's. Then what else was there? The line of symmetry between the two graphs, right, of the original function and its inverse is y equals x. Okay. Then to find the derivative of the inverse, right, we can simply use this formula, right? So inverse of the, derivative of the inverse of f of x, right? We simply calculate the derivative of the original function and take a reciprocal of it. Okay, and that's pretty much it. All right, so I'll see you next time.